So this week you have worked through a lot of lesson 5-6 in the Pearson textbook, and we've had some questions on example 5, the composition of functions to determine whether two functions are inverses of one another. And so Mrs. Conway and I wanted to show you kind of how your workstation might be set up and then work through that problem.
So we've got our computer logged into the Pearson example that matches with the workbook here. If you did not pick up a workbook, you're just doing this on notebook paper, but everything follows right along together. And you can kind of work and check as you go. So as I went along, I just kind of made some notes. Topic 5, lesson 6 is about inverses, and the basics are to find an inverse, you switch x and y, and then use algebra to get y alone. So that's the most basic part. If it's a table that they give you, all you have to do is switch the x value and y value. That's it. The domain of the original function becomes the range of the inverse, and vice versa, because the x and y have switched. And then you're going to hear them talk a lot about functions, and what a function is, just remembering, is that you only have one y value at most for any x value. So the function can't double back on itself. It has to pass the vertical line test that you might remember from another math class. So when I start talking about inverses, I always start with something super simple. Like if I'm going to take a number times 3, so 3x, the inverse, in order to find that, I switched x and y, and then I isolate the y. So in this case, all I had to do was divide by 3. So the inverse is y equals 1/3 x. And if I think about it from the start, if I took a number and multiplied by 3, how would I undo that? Well, I would divide by 3, which is the same thing as multiplying by 1/3. So these two are inverses of each other because they undo each other. So that's related to composition. When we look at the example on the computer, I'm going to let you guys go through the examples, but I really wanted to point out how if it really, you keep pushing next and you can see more and more and read more. Also, don't forget to arrow up here in the bullets because there's a continuation and you can see more and more parts. So what we're going to look at is example 5 in the try it. And A is a little less complicated than B. So I'm going to start with B. And they have the function f of x equals the cube root of x minus 1. And g of x equals x to the third plus 1. So to compose these, you'll see it written f of g like that, which means f with g of x plugged in. So that means I'm going to take whatever the g of x function is, x to the third plus 1, and put it in the f function in place wherever there was an x before. So what that looks like, I refer up here, I'm going to have the cube root of, in place of x, I'm putting this stuff. And sometimes I literally will circle it and then think about a circle here where x was minus 1. So this is going to be x to the third plus 1 got filled in place of x, and then the minus 1 is still there. And then simplifying that, the negative 1 and positive 1 cancel out. So I have the third root of x to the third root and the x to the third cancel out. So I'm left with x. So in other words, if I dropped the number 4 in here, the function g would do something to it, and then the function f would undo that, and I'd be left with my starting number, because these functions undo each other, and I know because I'm left with x at the end. I think that's all for that one. We may add some more, but that'll get us started.